Hi, guys. I hope you had a great long weekend, whatever that looked like for you, whether it was just enjoying the weather outside or having a barbecue with your family, whatever the case may be. I hope that you enjoyed the extra day kind of separated from school. Now, that being said, since we are back and we only have a 4-day week, I decided to only give one assignment this week. So 11.3 is all that you'll need to do this week. It'll be posted Tuesday, it'll be due Friday, so it's a nice long time. So today in 11.3, we're going to talk about area and perimeter. We already started talking about this in the circle chapter when we talked about area and circumference. Circumference is kind of like the perimeter of a circle. Very similar concept, and you can see those formulas here. So 1 out of the 6 types that you could be asked about, 6 shape types that you could be asked about, you already know how to do. So that's really nice. But we're going to talk about area and perimeter of all different types of polygons. So as you can see from this little section, there's no formal notes. It's just kind of having the formulas in front of you to refer to. So we're going to talk about the area of triangles and perimeter of triangles, the area and perimeter of rectangles, the area and perimeter of squares, the area and perimeter of parallelograms, the area and perimeter of trapezoids, and then the area and circumference of circles, which is kind of a refresher from last chapter, so that's nice. So there's no formal notes to fill in. I'll just say when we think about area and perimeter, the key differences between the two is the area is the space that the shape takes up. So if you look at your floor right now, whether you have carpet, you have tile, you have hardwood, you have linoleum, whatever the case may be, that area would be the entire space that that flooring takes up in whatever room you're in. That's how you find area. That's what we're talking about when we say area. Now, when we say perimeter, if you look at whatever room you're in, that would be like walking along all of the walls in your room. So perimeter is all of the edges of the shape added together. Area involves specific formulas based on the shape that counts the entire space that a shape takes up in whatever plane that it's in. So those are the key differences. There are formulas for perimeter, but if you just tell yourself you add all the sides together, you can always do that too. You don't have to use a specific formula. So that being said, let's get into some examples. I pulled these examples straight from IXL. They do get a little bit redundant, so if you feel like you've got a good hang on it, you don't have to watch this entire video. So the first question says, what is the area of this square? So it's a square. So looking above, I want to use the area formula for square, which is this guy. So I'm just going to copy that down so that I have it. I have something to refer to. So the area of a square is found by taking the side and squaring it. So that's my formula here. Now I know my side is 2 kilometers, so I can plug that in. So my area is equal to 2 squared, and then I know that 2 squared is 4. So my area would be 4, and then it's technically kilometers squared. Don't worry about filling in the unit. IXL already does it for you. You would just have to input 4. All right, so second question. What is the perimeter of this rectangle? Now, you can use the formula. I'll show you both ways. Or you can just use the trick I told you about adding up all the sides. So the formula for perimeter of a rectangle is perimeter equals 2L plus 2W. I don't know why this isn't getting skinnier. I'm trying to make it skinnier so I can write easier. So the length would be this guy. The width would be this guy. So I can plug that in, and I get 2 times 2 plus 2 times 1. Simplifying, 2 times 2 is 4, 2 times 1 is 2, and then 4 plus 2 is 6. So my perimeter is 6 meters. Now the alternative is you can go around the shape and add up every edge of the shape. So I know that this is 1, right? This is 2. This is also 1. And this is also 2. So I can do 1 plus 2 plus 1 plus 2, and that will also give me 6. 2 ways to approach the same problem. Number 3, we are going to look at the area of a triangle. Maybe this will work. So the area of a triangle is found by doing, nope, that's fine, 1/2 times base times the height. Now the base is always what the triangle is sitting on. So this is my base here, 16. And then my height is how tall the triangle is. So that would be this guy, which is 11. So I'm plugging in 1/2 times 16 times 11. And then I can either plug all of this into my calculator at once or take it 2 numbers at a time. If I take it 2 numbers at a time, if I do 1/2 times 16, that gives me 8. And then I have to multiply that by 11, and I get 88. So the area of this triangle is 88, is that miles? Looks like miles, squared. All right, number 4 is a review, but we'll go through it anyway. So the radius of a circle is 1 kilometer. What is the area? So again, area is equal to pi r squared for a circle. Now we already have r, so that's nice. So we can just plug that in, and I get pi times 1 squared. Well, 1 squared is just 1, so my area is 1 pi. I don't even need to put the 1 in IXL. I can just put the pi symbol, and then it would technically be kilometers squared. But again, you don't have to worry about the unit when you're plugging it into IXL. They already give it to you. All right, a couple more problems here. So if we look at number 5, now they're asking us for the perimeter. So again, the easiest way to find perimeter is just to add up all the sides of the triangle. So I have 10 plus 6 plus 8. So it's like walking along the edge of that triangle, and I get 24. So my perimeter is 24 kilometers. For number 6, this is a trapezoid. So this is our first example with trapezoid. So if we look at the formula sheet, this is my formula for the area of a trapezoid. So it's 1/2 times the height times the bases added together. So the area is found by doing 1/2 times the height times the bases added together. Sorry, this is so sloppy. I don't know why it won't let me make it smaller. So I'm doing, this is B1, this is B2. It doesn't matter which one's which. It just matters that you make the height. That's how tall it is. It's 18. Then I can plug in, and I get 1/2 times 18 times 6 plus 16. Now remember your order of operations here. You have to deal with the parentheses first. So I have 1/2 times 18. I have to do that 6 plus 16 first. That gives me 22. Then, looking at the first 2 numbers, doing my multiplication, I have 1/2 times 18. That gives me 9. Bring down the 22. And then 9 times 22 gives me 198. So my area is 198 miles, it looks like, again, squared. So it's just following the formula. As long as you plug in the values in the right spot, you should be totally fine. All right, a couple more examples. It does get a little bit more challenging here. This is kind of working backwards. We did this with the circles as well. So now we want to find the missing length. So we are looking at a parallelogram here, and they tell us the area is 77 kilometers. So you should be thinking to yourself, okay, I need to use the area formula, which from the formula sheet is base times height. Now you have to ask yourself, what are you given? Are you given the base and the height? Are you given the area and another piece? Because that's an important critical part. So I know the area is 77 kilometers squared. So I need to plug that in for A. So this is going to be, actually, let me move it here, 77. And then I know my base is 11. I don't know my height because it's labeled as P. So my base is 11. So plugging that in. And then I don't know my height, that's P. Now I need to find the missing length. So I need to solve for P. So just rewriting this a little bit neater, I have 77 equals 11P. In order to get P by itself, I have to divide both sides by 11. When I do that, I get P equals 7. So it would be 7 kilometers. So again, you're just working backwards here. Number 8 says, look at this square, find the value of Z. So now they're saying it's the perimeter. And I know the perimeter of a square is found by multiplying 4 to whatever the value of the side is. So they tell me the perimeter is 12. So I can plug that in. And then I don't know what this side is. They tell me that the side is equal to z. So I'm going to do 4 times z. In order to get z by itself, I have to divide both sides by 4. And then I'm left with z equals 3. So it would be 3 kilometers. Two more examples and we're done. So this is the same kind of concept, just with different formulas. So number 9 says, what's the missing length? And they give us the area. So in order to go backwards, I should be thinking, okay, how do I find the area of a triangle? Well, I find the area of a triangle by using the formula 1/2 base times height. Then I have to think about what I'm given. Well, I'm given the area, so that's A. I'm given the base, what the triangle's sitting on. That's 20. And then I don't know my height, W. Now, your height always corresponds to that right angle. Wherever that right angle is, that's going to be your height because that's the shortest distance from the top all the way to the base. So now I can plug in what I know. So for the area, I know that that's 140 equals 1/2. I know my base is 20. And then I don't know my height, but they labeled it W. So looking at the side that has the W, I have some stuff I can simplify. I can do 1/2 times 20. When I do that, I get 10 W. Now to get the W by itself, I have to divide both sides by 10. And I'm left with W equals 14. So it would be 14 meters for that length. That's how high my triangle is. It's 14 meters high. And then one last example, and I'll leave you to work on the IXL. So this is a trapezoid, and they want to know the missing length. So again, it's the area. So I have to think about what the area formula is. So area equals 1/2 times the height times the first base plus the second base. Again, it doesn't matter how I label my bases. It just matters that I label the height correctly. So wherever that right angle is, that's my height. So 14 is my height. I'll just label this B1 and this B2. And then I know my area is 210. Now I have to plug in everything. So my area is 210, and that's equal to 1/2 times 14 times my bases added together. So my first base is W, my second base is 18. This is the most challenging type that you could be asked, but it's totally doable. So here, looking at your order of operations, I can't do anything with that W plus 18 because W is a variable. I can't simplify that. So I'm actually going to start with the 1/2 times 14. So I can simplify that. 1/2 times 14 would just be 7. Half of 14 is 7. And then I have W plus 18. From here, I can distribute that 7 to both terms, and I have 210 equals 7W plus 7 times 18 gives me 126. And then 2 steps and I'm done. First step, I want to subtract 126 from both sides. So then I'm left with 7W, and then 210 minus 126 gives me 84. And then I need to divide both sides by 7. When I do that, I get 12. So my first base would be 12 feet long. All right, so that's the essence of this IXL. You have all week to work on it. I want you to now go to S13 and get to 80%. This might be a good spot to earn some extra credit if you're looking for extra credit, because this is a little bit easier of a lesson in comparison to some of the other ones. As always, if you have any questions, please feel free to email me, message me on Remind, or leave a little comment on Google Classroom. Thanks, guys.